Hi, everybody. Welcome to Developing Learning Environments this week in Early Childhood Education. We are on week 9 this week. I am going to just have one assignment for you to complete this week, which is the Chapter 11 quiz. So I am going to review Chapter 11 for you today, which is over developing science centers. So as we look at this, we look at science centers in early childhood. From a young age, children develop science concepts. Okay? And the science is more than just the experiments that we often think of with science, right? These science concepts provide a powerful tool for reasoning, helping children organize information and act as building blocks that allow children to make inferences, right, from analogies and extend knowledge. So these concepts reflect children's emerging theories about the world. And so helping children to understand how things work, make assumptions, make theories, make guesses, hypotheses, etc. So it all doesn't have to be within that that classroom setting, right? That science setting, but really things that they're doing every day in regards to organizing things, reasoning, are all part of that science process or science concept. And in the early years, children need to learn science process skills. Okay, so in the standards that we now use in science, which are called the next generation science standards, this is referred to as scientific and engineering practices, right? So that seems a little bit big in terms of terminology for our early childhood students, but we think of that as science processing skills, okay? Same thing as scientific and engineering practices. Children need to ask questions, define problems, develop and use models, plan and implement investigations, analyze and interpret data, use mathematical thinking, construct explanations, design solutions, defend positions based on evidence, and obtain, evaluate, and communicate information. Okay, so they also need to learn scientific content. So all those things that we talk about, that I just talked about, which have a tendency, in my opinion, to seem like that is too complex for early childhood kids to be able to use. We really have to break it down in terms of what those kids are capable of doing and what is appropriate for them in terms of what they are doing, if that makes sense. So even though these terms seem very technical, right? Construct explanations. Basically, that means they have to just be able to explain what they did. If they're in a block center and they're working on building a bridge or building something, can they explain why they're doing it the way they're doing it? Okay? Asking them about that. So that's kind of a simple way to explain these skills, these science skills that children need. What specific topic is being studied is less important than helping children to tie what is learned to concepts or big ideas. For example, it does not matter what animal is studied, but that children are learning about life cycles and living versus non-living animals. Okay, this right here on that piece. So the content is broad, right? So the topic, like what animals, what dinosaurs, what plants, whatever it is that you're studying, take that big idea and apply it to that. Life cycles, for example, living versus non-living, how you classify, how you organize things. Is it based on color? Is it based on size? Those different things are important. So what does an effective science center look like in your early childhood classroom? So they can focus or should focus on inquiry, okay? Focusing on a question or questions to answer, okay? Or discovery, exploring a science concept rather than a specific question, okay? They can also contain science inquiry tools to use in other centers. So 2 things that you can focus on, inquiry or discovery, okay? Answering a question or exploring a concept, okay, rather than a specific question. And so 2 different ways to focus your science center. The center should be located in a quiet area of the classroom near a sink and a window. It needs to provide adequate workspace for several or multiple children. There should be a bulletin board available for posting science information and findings. The science center can be made exciting through the design. For example, the center might be developed as a lab with science coats and visors with scientists written on them. And so there's got to be room. You should have access to be able to see outside if possible. If not, what can you do to fix that? Obviously, you can't put a window into your building, but you can maybe put up some poster of looking outside or an outside view and change that to different things throughout the year. Or you can put in, if you don't have a sink in your classroom, close like science classrooms do, can you get some water in there anyway to be able to wash hands and do the variety of those things. So you have to do the best with what you have in your building. The center should also be located in a, sorry, I read that already. Materials for the Science Center should focus on action rather than just looking. Okay, so encourage what-if statements and be relevant to the children, building upon their current knowledge and background. Okay, so you don't want to, if you have something totally brand new, kids have never heard about before, then you're going to have to introduce that. You're going to have to help in that aspect in regards to exposing them to these brand new things. Okay? You can't just give them something totally brand new they've never heard of, never had any connection to, and expect them to understand it and dig right into that. Materials should be chosen that encourage process skills, help children learn specific content, and are tied to overriding concepts. The center also needs to contain resource materials, inquiry tools, and materials so children can represent their knowledge. Either open-ended materials of a variety of tasks need to be available to allow children to succeed. Right? The center needs to be designed so that children can use materials independently, and information for adults such as science content, background sheets, overriding concepts, and a list of vocabulary related to the topic being studied provides information to facilitate learning. Okay? So I went through quite a bit there on some of the materials, right? But things that kids can do independently, that they're able to work together with the other students on, and also things for us as adults, right? What are we covering? What vocabulary words do we need to make sure we're interjecting into the center, right? If there's key technical terms that you want the kids to know, then you have to use them. Okay, when you're observing and they're not using the terms, maybe they're just saying stuff or things or whatever it might be, you want to interject those terms so that they hear them, right? If they don't know those terms, how do we learn them? How do we understand them? We hear them used in the appropriate setting. Okay, so the vocabulary and the terms and the concepts are important for us as adults to have. And not just us as the teacher, we might know what it is without having it listed, but what if we have a teacher's aide in there, a para, a sub, a guest, a parent, whatever it might be. Those terms, those things for the adults help the others who may not be as familiar with the center to be able to engage the students in there as well. So possible science centers can focus on a lot of different things. Using science tools specifically, you can focus on physical science, life science, earth and space science, engineering. All those are important parts of the science, and you can rotate them through, and you should rotate them through so that your science center all year long is not just focused on science tools or life science or whatever it might be. It's important to be aware that the national and state science standards, which are now the next generation science standards, are important to include, and then the learning outcomes are important in those planning the centers as well. So we should strive to understand children's current theories and misconceptions about science as well, so that we know where they're coming from and we can design an appropriate center so that it's not too easy or too difficult for them. If we're looking at infants and toddlers, actively investigate their environment by using observation and prediction to make sense of the world, right? So in a science center for infants and toddlers, it's going to be not the same as we would use for a kindergarten or first grade classroom, okay? Materials should be added to the environment that will enhance this natural curiosity. Typically, these will be added to existing centers rather than being a separate center, okay? So you can combine your science concepts with other centers that you might have in that infant and toddler classroom. Teachers facilitate learning in the science area by determining the concepts to be taught, choosing developmentally appropriate activities, determining children's current knowledge and theories, including materials, and developing interest. These are all things that I've kind of briefly talked about, right? But you have to know your students, where they're at, where we're going, what standards you're looking at. Assisting children to build a mental structure, teaching children scientific vocabulary, providing background knowledge, asking open-ended questions, encouraging children to reflect upon their learning, implementing group science talks, encouraging and modeling curiosity, inquiry, enjoyment of science. So the more we model and engage in the science center, the science processes, the more students should engage in that as well. We talked about implementing group science talks. What does that mean? So you have, center time for a book, for example, that you're reading. So maybe you focus on a book specifically about science or physical science or scientific tools, whatever you might be studying or working in that science center. Have some small groups of those, have them talk about the book, the processes, the tools, the type of science, the things that you're learning. So engaging the students in some more of that talk and using that language themselves that we might be teaching them is a good way to help facilitate that science classroom and the science center. The early childhood years provide the foundation for lasting science learning, just like they do math and language and all these different content areas. Science can be an equalizer or a gatekeeper for later success. Historically, and even currently, girls, children of color, children with disabilities, and children who are poor are often excluded from science-related jobs and education. So our job as educators is to make sure that children are exposed and that they, as much as possible, and understand the science component and the importance of science in the classroom. Now, I know that science is not as big of a focus in our elementary, middle school classrooms as math and reading or language arts because of our testing at the state level. But it is important, and we don't have as much time typically. But the time that we are given for those this content in our classes is important that we take advantage of it and make it as interesting and appropriate as possible for our students. Okay? That is chapter 6 in terms of developing the Science Center for this week. Chapter 11 quiz, make sure you take that and by next Wednesday at 8 a.m. And if you have questions or need help on anything, please reach out and let me know. Otherwise, we will talk to you next week.